Hey, it's Doc Williams, and in this video, we're going to look at basic multiplication and division problems with significant figures. When multiplying and dividing with significant figures, first you perform the operation, which is multiply or to divide. Then you want to round your answer to the least number of significant figures that's in your problem. Let's follow this with number one. 2.9 times 56.3 is 163.27. 2.9 has two significant figures. 56.3 has three significant figures. Because 2.9 has the least amount of significant figures, my answer can only have two sig figs. There's a couple of ways that I can write this number showing two sig figs. I can write 160, and because I did not put a decimal here, this means that this is two sig figs instead of three. Remember, trailing zeros do not count toward significant figures. The second way to write this with two sig figs is 1.6 times 10 to the second. While the exponent tells us that this number is 160, we only consider the numbers before the times 10 when determining our sig figs. So these are two different ways that we can write this answer to the correct number of sig figs. Let's look at number two. 0.35 times 1.006 gives 0.3521. The first value of 0.35 has two significant figures. Remember, leading zeros do not count towards sig figs, but because these two zeros are sandwiched between two non-zero digits, then we have four sig figs. If you need a quick review on how to determine sig figs, go back and catch the video, Rules for Determining Sig Figs. Now, since the least amount of sig figs in my calculation is 2, then my final answer will be rounded to 0.35. We're keeping this 5 instead of rounding up to 6 because the number right behind it is below 5. And if you wanted to write this in scientific notation, we can write 3.5 times 10 to the negative 1. For number 3, 36.2 times 0.1 equals 3.62. Pause the video, determine how many significant figures are in each of the numbers in the calculation, and then round the answer to the correct number of sig figs. 36.2 has three sig figs, while 0.1 has one sig fig. So your answer would need to be rounded to one significant figure. In this case, 6 is above 5, so we will round the 3 up, and your final answer is 4. Now pause the video, complete the calculation for number 4, and write the answer to the correct number of sig figs. 6 times 1.9 equals 11.4. 6 has one significant figure and 1.9 has two. So since 6 is our least number of sig figs, we need to write our answer to one significant figure. And to round 11 to just one sig fig, we're going to use this 1 to determine if we need to bump up 1 to 2 or keep it the same. Since it is 1, we're going to keep it the same, and our answer is 10. So let's do one more example. Number 5 of 2.0 times 20 with a decimal. Well, 2.0 times 20 equals 40. And 2.0 has two significant figures because although this 0 is behind the 2 with nothing else behind it, it is behind a decimal and a non-zero digit, which makes this 0 significant. And this decimal behind this 20 makes this 0 significant because it is telling us that this 0 is counted in the calculation. So we have two significant figures there. As written, our answer has one significant figure. What do you think we need to do to this answer in order to move it from one significant figure to two significant figures? One way to write this would be to write it with a decimal behind it, just like we have with 20 decimal. Writing the decimal behind the 0 makes the 0 significant. Or we can write it in scientific notation, 4.0 times 10 to the 1, where the 0 is following a non-zero digit and a decimal, which makes that 0 significant. Either of these two ways are acceptable for writing this answer to two significant figures. Now let's look at division. Following the same principle for multiplication, 13.1 divided by 9 equals 1.45 5, 5, 5, and several other numbers. Now I wanted to write this with enough calculated digits to help me be able to round to my correct number of significant figures. Going back to my problem, 13.1 has 3 significant figures, while 9 has 1 significant figure. And just like with multiplication, I am not worried about the number of decimal places. I'm worried about the overall number of significant figures. And since my least number of significant figure is 1, my complete answer must be written to 1 significant figure. I will use the 4 to tell me how to round, and the answer to the correct number of significant figures, which is 1, is 1. Looking at number 2, 124.96 divided by 3.3 is 37.86667. Again, I'm just writing enough calculated digits so that I will have enough to round to the correct number of significant figures. Going back to my problem, the first number has 1, 2, 3, 4, 5. Since all of these are non-zero digits, I have 5 significant figures, and the second one has 2 significant figures. So I want to make sure my final answer is to 2 significant figures. So I will use this 8 to tell me how to round the 7, and since 8 is above 5, then I'm going to kick this 7 up to 8, and my final answer to 2 sig figs is 38. Going to number 3, 0.529 divided by 2 is 0.2645. Now pause the video and determine how many significant figures you need to write this answer to. Our first value has 3 significant figures since the 0 is a leading 0. And our second value has 1 significant figure. So that means my answer must be to 1 significant figure. I will use the 6 to tell me how to round a 2. And then my final answer will be 0.3. Pause the video and go ahead and complete number 4. 1.67 divided by 0.25 is 6.68. 1.67 has 3 significant figures, 0.25 has 2 significant figures. So my answer will be written to 2 significant figures. I will use the 8 to tell me how to round the 6. And the final answer to 2 sig figs is 6.7. As always, thank you for watching.